someone asked regarding the Sentinelese. Okay, he spelled it wrong, so I hope he corrects that next time. These are people who live, a lost tribe, so to speak, that lives in, even today, in a little island known as Sentinel Island. That's why they're Sentinelese. It's an island that belongs to India. It's in the Indian Ocean between India and Thailand and Vietnam, those countries over there. Somewhere in between those two regions, it's Sentinel Island. And we have these people that live there. There are maybe only 150, 200 people. That's all that's left. And there were like 3,000 of them in the 19th century. So they've lost a lot of folk, a lot of members in the tribe, and maybe they're on their way out. Aside from the fact that they probably lost quite a bit of genetic diversity. Okay, and so this is what I'm talking about. I talked about it the other day. Apparently, sometime around 60,000 years ago, that's the theory. Some black people left Africa, and that's why these people are black, because apparently they had their origin in Africa. And the theory is that they went along the coast and somehow ended up in Australia, and a group of them somehow ended up in that, where you see the circle there, that's where the Sentinel Islands are at. There's a north and a south one, and these folks live in the North Sentinel Island. This is what that island looks like from a bigger picture of it there. And so again, there's a few people who live there, and they're protected by the Indian government in great measure because a lot of people want to go over there, and talk to the Sentinelese and so on. But the Sentinelese are very violent people. They kill anyone who comes to their island, and nobody holds it against them because they say, well, these people live out there in the wilderness. They do hunter gathering. They don't know anything about civilization. And here's a picture of these. You can call them Indians because they are truly Indians today. They're citizens of India without passports or any documentation. But this is more or less what they look like on that island. And you can see the bottom left one there. They're shooting at a helicopter. They're shooting arrows at it. They probably don't even know what that is. How's that big bird flying out there? Anyways, these folk are not very friendly for whatever reason. And again, they're being protected by the Indian government. So what's the issue? A fellow asks a question or made a series of comments and questions here. He says, might have lost genetic diversity long before, and yet they are surviving even now. Yeah, they're very likely low on genetic diversity, okay? But I suspect that if we took their DNA, we would find that they're very similar to humans today, even though they would probably be, on the outskirts of our genes. They're still very close to us, I think, simply because of how many thousands of years they've been around. And my take on this, that these Sentinelese, they don't date from 60,000 years ago. Again, this is my personal view on this. I think they probably occupied those islands a lot more recently, maybe in the Neolithic. That's my guess. Anyways, says in the last video, you said there might be some pockets here and there. He's talking about pockets of humans that might survive on the planet once the global economic collapse happens, which is my theory for the extinction of man. I'm saying that the global economy is going to collapse. When that happens, not if, but when, no one's going to produce or distribute food, and most of humanity will die. That's my take on that. And I think that some pockets of people will survive here and there on the planet. They'll be very few and far apart, okay, when that happens. And so, yeah, so what happens when that happens? What happens afterwards, okay? And this fellow is talking about the Sentinelese. He said they might have killed, dried, and kept humans for later consumption. No, I don't think so. I don't think, see, they've killed a couple missionaries. In fact, a few months ago, that's how I heard about the Sentinelese. They killed a missionary, and that's how they came into the news, at least from my point of view. And what they did, apparently, they buried that human. They don't eat human. They're not cannibals as far as we know, okay? And he continues, says, and they would rape women with them, and they are not, if they are not willing partners. Anyone who survives, you shouldn't be talking too much about rape. I don't think they're going to have time for sex as much as for something more pressing, which will be subsistence farming. They'll be producing food, okay? And people have this mind, stuck on this day and age where everybody can see sex online, and there's they're into a lot of sex. playboy, hustler, and so on. After the collapse, there's going to be no sex, at least for reproductive sex, which is what this fellow has in mind. There won't be any sex in that sense. They might have sex, of course, but I don't think they'll be thinking too much about sex. They'll be more worried about food, about producing food. And there'll be very little time, very little energy to have sex. Whenever they do have sex, they're probably going to be a lot more philosophical than we are about today, because they're going to be thinking about all the humanity that departed. I think that's going to be undermined. They're going to be probably remembering the old days. And then, for sure, if they have sex, it will not be reproductive sex, mainly because the females will not want to have a baby. You're talking about city folks here primarily that might survive. And they're not going to have babies without doctors, without hospitals, without anything like we used to in the old days, in a cave. I'm not sure how many women will want to do that. That's one issue. The other one is that even if they do decide to have sex, or they have an accident and become pregnant, and they do have the kid, it's not like they're going to restart the race. It's not going to be an Adam and Eve situation, because on the one hand, they lost their genetic diversity, meaning that 3 or 4 generations later, it's the end of humanity anyways. Who knows what's going to come out of there. And second, it's not going to balloon. It's not going to be exponential reproduction. If anything, they have one and that's it, and that's the last human on Earth. It's going to be like that. Okay, so, but again, this fellow has it the other way around. He says that way they can survive and probably increase in number as their population pyramid will be of normal shape. Absolutely not. Their population pyramid will simply be more pronounced in the sense that more folks will be old and very few will be young. We will not be reproducing. We will not be producing children. Okay, not in quantities. If anything, one by accident, but not deliberately. Who's that fella going to marry? I don't know. If there's only 10 or 20 in the group, it's not like they can produce 100 out of there. More than likely, you're going to have already an inverted pyramid, population pyramid in that group, and the only thing they can do by accident is produce fewer children, which will, in the next generation, produce even fewer children. The fellow says, well, okay, if they can increase in number, they are at least 2 communities that can meet after a few millennia. Okay, provided they survive till then, they would have 2 different gene pools. Again, first of all, these pockets will be few and far apart. They will not have children. They will treat another group as enemies if they're too close together. Okay, more than likely they'll be so far apart and too worried about producing food that they will not be thinking about going to so far away from where they're at to see if there's other humans out there. They're not going to venture too far apart, far from their camp. Okay, so I think this fellow has most of his stuff upside down. He's thinking in terms of today and maybe in the days of Adam and Eve, in the Paleolithic. This is going to be totally different. This is going to be, if they survive, it's because they're planning and not because they're hunting. I don't think there's going to be any hunting. There's going to be nothing to hunt after most humans are wiped out by hunger. They're just going to kill every animal in sight. And whoever survives will have to depend on planning. And that means they had to plan in advance in order to plant in the future. Okay, that's one issue. The other one is that they're going to be so busy with subsistence farming and taking care of their food supply for the next winter or next summer, that they won't have time for a lot of this other stuff, like going out there and looking for other people. So, and even if they do, remember one thing: whoever survives will already have start out with exhausted genetic diversity. In other words, there's going to be no genetic diversity. We already have none among humans today. And here, let me give you an example of that. Okay, here it is. Came out in 2012, but there's been a couple reports on that, and also sets of data out there. It says chimpanzee populations. Listen to this. Troops. That's what they're called. These chimpanzee populations living in relatively close proximity are substantially more different genetically than humans living on different continents. Okay? If you take the entire human race, 8 billion of us, we're down about every one of us. Maybe the Sentinelese will be an outlier in that group, okay? But if you take all humans today, we are all brothers and sisters from a genetic point of view. There is no, we're all clones. We're all clones. Anyone who you marry today, you married your sister or your brother. Okay, from a genetic point of view. That's how close we all are, all of us. So, right now, if a pocket from that group survives, their genetic diversity is not going to increase. It's going to, if anything, decrease. Okay? So keep that in mind. We cannot increase our genetic diversity anymore. And that's a long story. I have a graph that shows that, but I talked about it in the past. I'll bring it up some other time. I got it also in my book, the Neanderthal book. But the issue is you cannot increase genetic diversity. And the main reason there, you need a different environment to create genetic diversity. We don't have it. We can't have it anymore. Even if you go to the North Pole, you're not gonna go with your skin. You're gonna put something on. That means you're gonna bring your environment with you. So you're not gonna change, and it takes thousands of years to change anyways. So it's not gonna happen anyways, and it's never gonna happen again. We can only lose from now genetic diversity from now on. So whoever survives, whatever pocket, they're already starting on the wrong foot. They're already starting out without any genetic diversity. Quite different than what happened in the Paleolithic or the Upper Paleolithic when the Neanderthals went away about 50,000 years ago. Really, they went away, they say, somewhere around 40,000 years ago, which is when the Mousterian technology that they used apparently disappears. Okay? So at that time, we had quite a bit of diversity in our genes and so on. But since then, all we've done is lose, and today we're all clones. Okay, that's essentially the story. And people say clones, but a black guy from Africa and a yellow guy from the Orient and a white guy from the West, you take our genetic code, like I just showed you there, we're all alike. Maybe the guy is black, the other guy's yellow, I'm white. You take our genes, we're all the same, essentially. There's not that much difference between us from a genetic point of view, and that's got to do a lot with disease. Okay, that's the sifter, but I've talked about that in the past. Okay, let me continue here. One fellow talks about fertility, okay, and he says the following. He says fertility rates were very low before the advent of agriculture. I don't subscribe to that theory. I think it's the other way around, or I make a different assumption. I'm saying that fertility rates were very high. The problem was that most of those children died for different reasons, and humans did not live very long either. It was between 20 and 30 years and they would die. It was a very short lifespan. Today we live to the age of 70, 80, 90, 100. That wasn't the case, 40, 50,000 years ago. No way. In fact, just at the turn of the century, the 20th century, the average age, 1900, was around 40. Today it's a lot higher. It's like 67 or closer to 70 maybe. Okay, and that's because some people live to 100, others people live to 60 or whatever, 50. But the life expectancy of humans has gone up dramatically in the last century alone. And before that, people would die very young, especially children. They would die. In fact, one calculation is that in around 1800, about half of the children below the age of 5 would die. That's how familiar we were with death. Today, you don't see death anywhere. If you want to see death, you got to see someone kill someone or some accident or something like that. People don't die today. Okay? At least not. We don't see that as common as in the old days. In the old days, people would die from disease. Okay? Today, nobody dies of diseases. We die of old age ailments. We can't live forever. Okay? I know that. Okay, what do you think the mechanism is for people deciding not to have children? It's not that people, no, yeah, to some degree, people decide not to have children because it's already in our culture. It's a question of culture of the cities. And there you see the reason, density dependence. Density-dependent birth rates, that's what it's called. And the example that I always try to give is that when you have a lot of bacteria or fungi or whatever in a small space, first they multiply. Like there you see how they're multiplying. And then at some point, they reach saturation and the population pyramid overturns. They don't have enough stuff to eat. They don't have enough space. Density has grown too high, and at that point they stop reproducing as much as they did in the past. So the first growth is exponential, and the decline is also exponential. They finally succumb to the amount of space or the amount of food or resources. And so the fellow says, why do the cities cause people to not want them? Yeah, and again, it's got to do with density dependence. I think the numbers were artificially inflated by the utility of children before technological societies made them obsolete. Yeah, it's got to do with the transition from the country to the city, which is still going on today. But essentially, what we see today are cities, big cities. And what has happened is not that we produce so many children in the cities, but that people from the country were bought out. They were living in farms. They had many children. They moved to the city to look for jobs. And today we have all these enormous cities, these enormous ant holes, and the country has been left in the hands, or is being increasingly left in the hands of agricultural corporations that produce the food that feeds the cities. That's the model we have today. Okay, and here's the world population. Okay, you can see how the numbers increased through the ages. Okay, and if you look at it one more time, this is from like I think the beginning, yeah, the beginning of the Christian era, and you can see how we've multiplied. Most of them in the, you could say, certain regions close to the equator, not quite the equator, but you can see that way up north and way up south, there's relatively few people, and then a lot of those that you see there are primarily big cities. That's where people are at today. Okay, and the way I like to look at this is through a chart. Okay, and I call it the curve of life. Okay, and this explains what this fellow is asking. For a long period of time, we had births approximately equal deaths. So there were lots of births, but also lots of deaths for different reasons. Then towards the end, and this applies to any species almost, practically. I mean, if there's any exception, there's few of them out there. Most of them will simply be that follow this curve. Some will be longer, some will be shorter, some will be taller or smaller. But the point here is that the shape of the curve applies to almost any species. And again, the first part is births approximately equal to deaths, just a little over deaths, so that population increases very, very slowly. Then at some point, and this is again towards the end of a species lifetime, okay, births start being greater than deaths, and that's because the species has become sedentary, and they get used to endemic diseases. Primarily, that's the reason. And the diseases that used to kill them in the past no longer kill them. They might make them sick, but most of the population survives. Then at some point they reproduce because now births are greater than deaths, and they reach a point where again, they live longer, and so deaths now become greater than births. And shortly after that, we have that both deaths and births go down. In other words, births are less than deaths, but fewer births and great deaths. That's what's happening, and that's what leads to extinction. Now, you're probably going to hear out there or see out there the S curve. The S curve that they have out there stops at births greater or approximately equal to deaths, which is that high point there. And they say, oh, there's your S curve. They never finish the S curve. The S curve ends in extinction. Okay, that's my take on that. Okay, so whenever you see the S curve, ask them to complete it. What happens after the upper part of the S? I'm saying it goes all the way down to extinction for populations, okay? Okay, another fellow asks along the same line, the angiosperms had an effect on the plankton food supply. I don't think so. He's asking that. Apparently he was answering someone else, okay? But someone else brought another question along the same lines, and it says plankton and conifers have genetic diversity in common. Yeah, what he really meant, I think, okay, I don't want to put words in his mouth, but I think what he's saying is they have in common the fact that they either had lots when they started out and very little when they ended. Okay, that's what he's saying. He says that more or less in the next sentence. He says they went extinct because they lost their genetic diversity. So that's what they had in common. And their population pyramid overturned. And so let me double up on that. Okay, and so this is the notion here, you could say the theory. And I'm going to look at one example, which is just one food chain, which I've looked at. There's others out there, but this one I think illustrates quite well what happened in the Cretaceous, and this is in the seas. Okay, you had the plankton that was up to the KT, the Cretaceous Tertiary boundary. That was large. It was large plankton. Okay, then it was replaced by small plankton after the KT boundary. In other words, our era, the era of mammals. In the seas, we had small plankton that replaced the large plankton that died at the KT boundary, more or less. Okay, Mosasaurs ate ammonites, which are those curlicues there. Ammonites fed on plankton, on the large plankton. Now, if they ate large plankton because the small plankton were too small fries to eat, or because it wasn't the same region, or for whatever cause, it doesn't really matter. The point is that what disappeared were the large plankton, the ammonites, and the mosasaurs. That entire food chain went away. What survived were the small plankton, foraminifera, called also forams. Okay, and let me remove this. Okay, and so here's what it looks like. Okay, The KT plankton and conifers have in common that. Population pyramid overturned. Okay, so that's doubling up on this what this fellow said. And they both lost genetic diversity towards the end. And you can see there the differences in the foraminifera that existed before the KT boundary and after the KT boundary. You had the dinosaurs on the left-hand side and the little tiny mammals on the right-hand side, so to speak. Okay, you had small forams replace big forams. That's essentially what happened in the seas. And the numbers decreased in the last few million years of the Cretaceous. That's what happened to the forams. Okay, so their numbers started to decrease not only for the forams but also for the conifers. Okay, the varieties also decreased. Okay, I'll show that in a second. Conifers, especially cycads and cycadioids. Okay, Williamsonias and so on. Those were the ones that disappeared at the KT boundary. You can think of them as cactus-like or palm-like trees. Okay, that's what they look like. And they were crowded out by the angiosperms, which were dotting the land. Okay, plankton crowded out by smaller species. Okay, and again, it's very likely that the small plankton started occupying the same niches as the large plankton. And the large plankton were being eaten up by the ammonites, which were eaten up by the mosasaurs. And when they went away, what remained were the small plankton, which were eaten by fish and other animals that survived, maybe turtles and who knows. Okay, here's the Cretaceous terrestrial revolution, which tells us what happened to the conifers. This is on land. Okay, this is a 4-year study that they collected this information, so it's a pretty good graph, I think, that shows what really happened. And that's about midway into the Cretaceous. You can see the angiosperms are muscling aside all the other types of plants that existed until then. The ferns had been muscled aside by the cycads somewhere around the turn from the Triassic to the Jurassic. That's when the ferns started going away, especially the seed ferns. And the cycads, the Jurassic is known as the age of cycads. Well, they had to come to an end as well, and you can see that hump there, the green one, and the blue one. Those two humps, that's when they turned the corner. About midway into the Cretaceous, the cycads and the ferns started going away, whatever ferns there were, and the cycads had muscled them aside already quite a bit, and now the angiosperms are starting to muscle aside all these other plants, kicking them aside, including the ginkgos. Okay, we only have one species of that today, the biloba, and I think this explains in quite a bit of detail what really happened, and that's that the mammals grew or expanded, radiated with the angiosperms, and the dinosaurs came into an end because the cycads were coming to an end, whatever they ate, and I think it was cycads. Okay, their forests, their jungles were islands that were shrinking. Okay, so I call it the shrinking island theory because the islands that fed them were becoming smaller and smaller and smaller, so the dinosaurs could no longer radiate as they did in millions of years before that. There were not as many niches to occupy. They simply settled wherever they were, and they were becoming fewer and fewer in quantities and in species, number of species. Why? Because their island was shrinking. And part of the cause of that was the fact that the angiosperms were expanding and occupying the land. As far as the dinosaurs were concerned, those were weeds, and what was expanding with those angiosperms were the mammals, and that's us today. Okay, and so what is this about? Well, it's about what I call the first the population pyramid overturn, okay, which is followed by the ecological pyramid overturn. What am I talking about? I'm talking about the fact that for plants, okay, they had to come to an end at some point in time. They lost genetic diversity, and eventually they became old. And old meant overturning of their population pyramid, meaning that the last plants of each of these dynasties that existed until then, they had become old. They grew big. They had fewer seeds. They probably grew vegetatively at the end. And well, there are several criteria for determining when a species is old. Okay, I've gone through that in the past, and that's called an overturning of the population pyramid. And when that happens, the animals that depend on those plants and develop millions of years relationship with them, they go as well. And that's what happens at the bottom. You can see that what happens is as the green part there, the overturning of primary production goes from many to few. The herbivores go from many to few, and the predators, at that point in time, they're expanding at the wrong time, taking care of all the herbivores, which are also suffering because there's less food to go around. So those are the two mechanisms. The first one being the population pyramid overturn, followed by the ecological pyramid overturn of the animals. And we have a case, the Mouse Utopian Universe, carried out by John Calhoun, I guess he was a biologist, he was a psychologist really, but he studied it from a biological point of view. And then at the bottom right, you see what happens to humans. Our population growth rates have been going down since 1963, and we cannot stop it. And I'm saying the reason we cannot stop it, and we won't stop it, is that we've come to the cities. We don't produce children in the cities. So that curve shows exactly what's happening to man right now. We are going to approach maybe around 2050, mid-century, zero population growth. And I don't think we'll ever get there. That's my take on that. I'm saying it's going to occur much sooner than that, because what's going to overtake the total overturning of the population pyramid that would occur naturally is the collapse of the global economy. That's where we're going to die. We're going to die in a mass extinction, not in a background extinction. It's not like humans are going to die all alone and all the other animals continue. No, it's not going to happen like that. We all die in a mass extinction. You can call it the sixth mass extinction. That's, a lot of people say, is already undergoing right now. It's been happening for maybe thousands of years. Lots of the mammals out there are disappearing all around us. We have very few of them out there because very few species and very few numbers within each species. Why? I mean, lions were, I read 150,000 just around 1980s, 1990s. Today there's only 35,000 of them. They're going away. We don't need lions. We're encroaching on their habitat. They have no place to run. Their island is shrinking. So are the animals that they eat. You know, we have them just for sport, for entertainment, for fun. We go on safari, take pictures of them. You know, it's fun. And the animals are disappearing all around us. Why? We don't need those animals. What we need is cows, sheep, pigs, chickens, you know, the ones we've domesticated. Those are the ones we eat. And those have lost, a lot of them lost their genetic diversity as well. So all the mammals right now that are important, that are numerous on the planet, including us, we're on the way out altogether. Okay? And for sure, if the economy collapses, we're going to accelerate that process. It's not going to be an overturning of the population pyramid. It's going to be an overturning of the ecological pyramid. Okay, talking about Neanderthals. Here's a fellow says, problem is you have as little proof they didn't exist, they didn't as anyone has they did. You weren't there and neither were they. Well, he was talking about, I think, the Denisovans and the Neanderthals, that we have very little information about them. So there's a lot of stuff we cannot talk about, or that we're speculating on, because we were never there. You know, 40,000 years, 50,000 years ago, people today who can do a study, you know, they can't go back in time unless they believe in general relativity. And so we have no idea, not that we don't have any idea, but we speculate a lot of what could have happened to these animals, whether we mated with them. I think that's what he was talking about, whether we mated with the Denisovans or whether the Neanderthals mated with them, whether it was interbreeding, whether it was admixture. That's the issue. And yeah, the way this works is you get very few pieces of evidence. Okay, and this is much worse than for a murder trial. You know, murder trial, typically detectives have a lot more information than what we have of Denisovans and Neanderthals. We have very, very little information. And so all we can do is take all these pieces and try to imagine what could have happened, and there are different theories. And, you know, some you subscribe to and you use those as a foundation for a new theory. We call those assumptions. Okay, and all I can tell you is what, you know, the way I look at all this stuff. Okay, and here's evidence, proof. This is what I base my assumptions on. Okay, based on this information, on this evidence that we collected out there. And again, evidence for a jury trial is for belief. Here we're not talking about belief. We're talking about collecting evidence only to formulate an assumption. And you might form a different assumption than me from the same evidence. And that's fine. I can only tell you what I work with. Okay, and so this is what I work with regarding Denisovans. And I'm saying we didn't mate, as this fellow is insinuating or addressing. I don't think we mated with them. I don't think we had admixture. I don't think we had interbreeding with them, because they were more or less like gorillas. It was a different species altogether. That's my take on this. That's the assumption I make. Where do I get this? I get it from the evidence that I find out there. And let me show you what I find. Okay, these are the teeth that they found from Denisovan 4 and 8. And again, we have only 6 pieces of Denisovan today. We have 3 molars, 1 splinter of a bone somewhere. They don't even know what part of the bone it's from. We have a mandible, and that's about it. And I just want to compare the Denisovan 4 and 8 molar, the same molar, with the Neanderthal molar and the present-day human molar. Well, you can see that they had very big teeth. And to the right, I show 3 different species, completely different. The chimp, the Australopithecus afarensis, and a human. And the afarensis there, the one that I'm interested in there, you can see their molars were bigger than ours, much bigger, almost twice as big. And if you look at the Denisovan, again, it's bigger than ours, and if anything, it approaches the afarensis. And so the afarensis, like I showed the other day, looked like a monkey. Okay, he looked nothing like us. And so the question is, what did the Denisovan look like? Did they look anything like us? Would we recognize a Denisovan out there in the middle of nowhere? And I'm saying yes, that we would. We obviously would recognize a Denisovan because if you look at those teeth, you're saying it probably looked more like afarensis than it did like a human. And I'm sure that a Neanderthal would have also recognized a Denisovan quite easily. So I don't think they made it either. I don't think Neanderthals made it with Denisovans. Where did they get this? Well, they get this from geneticists. I talked about that the other day. The geneticists have taken over the Neanderthal extinction business. And they did so because they essentially opened a cottage industry for geneticists. So now the people who call the shots are no longer the paleontologists. You know, they studied morphology, physiology, all that stuff. That's no good as far as the geneticists are concerned. They say we have solid evidence, and the solid evidence is we do a genetic study, a genome maybe, okay, and they look at all the base pairs, all the comparisons there. They say, well, we have 2% commonality with the Neanderthals. Where did we get it? We had sex. And then we had the Neanderthals and the Denisovans, and they have some commonality. Where did they get that? It must have been sex. And we have some commonality with Denisovans, so where did they get it, or where did we get it? Well, we get it also from sex. And so everything is sex, according to the geneticists, and that's the only theory they've got. And it created a cottage industry for them. They have job security. And the people who lost control of that are the people who study paleontology, like Neanderthal paleontology. Those people have lost completely because they have no say in the matter anymore. If they want to know how the Neanderthals disappeared, how the Denisovans disappeared, they have to go to the geneticists, and the geneticists will tell them. They say, hey, you know, it was all these genes, we had sex with them, and they were a smaller population that was diluted into ours. And that's it. That's all you hear about from now on till the end of human existence. And so yeah, it's been taken over. Neanderthal business has been taken over by the geneticists. They tell you how many diseases we inherited from them, how many we gave to them, and if you want to know how much DNA you share with the Neanderthals, go get your DNA or genome or whatever analyzed, and they'll tell you, and they'll say, oh, your mother was a Neanderthal. That's where we stand today. So don't expect anything different. From now on, it's going to be admixture, intermarriage. That's what happened. That's how they disappeared. That's it. And it's not going to get any better than that because, again, the geneticists have taken over. And, boy, that's ballooned. That's ballooned. Every geneticist now is in the Neanderthal business. Okay, I suggest that people tell me if they want to write something, comment, whatever. Start by telling me how animals in the past became extinct, okay, before you tell me how humans will become extinct in the future, okay? If you don't know anything about extinction, much less can you tell me anything about human extinction. Show me you're an expert at extinction, and then we'll know that you can have a theory about the extinction of humans. And the homework question again, I'll put it over here, and it's that you got to tell me, if you can, right, why the animals on land disappeared at the same time, more or less, right, as the animals in the seas.